Hello. Uh, let's see. All right, everything should be working properly. Um, so today I'm gonna continue working on the renderer, and I've laid a basic outline for what to do from here on. To get anything rendered to our screen, even to just clear it. Uh, we need a bit of work since we need to be able to send commands to the DirectX API. So far we have built different structures, or rather abstractions around different DirectX and DXGI structures that allows us to initialize different components, of which the most important going forward will be the device. Um, so yeah, so far we've on the hardware level fetch the factory that allows us to create interfaces for different components. Then we fetch whatever hardware adapter we can find, and we create a virtual adapter, uh, which is called a device. We also created our swap chain, which is actually based on the hardware, but uses which uses different DirectX12 API components. Yeah. So right now we create the swap chain, but we don't do anything with it. It's because we want to, let's see, I'll draw it out. Uh, or perhaps we want to do a draw IO. Is it possible to do appearance stack? All right, there we go. So we want to, let's see, uh, we want to have an output of the swap chain that's a render target. And we want to be able to register commands, different GPU calls. For instance, maybe we want to draw a set of vertices. We want to submit these uh, uh, and we want to process it through a pipeline. so that which is our actual shaders and so forth. Uh, and we want to end up with something like a render target output. The swap chain will have two render targets. We will always let's see, am I allowed to do a that got weird. Yeah, like that. So we swap the render targets and just render to our current back buffer. So actually maybe we should we have a swap chain which kind of, let's see, if we move that around. We flip whatever render target we have. Let's see if we move these a bit down. We register and submit our commands. Perhaps we should let's see, something weird is going on with the sizes. Oh well, doesn't matter too much. Anyway, we want to register our commands, submit our commands, and pass them into our pipeline, and run whatever commands we have registered. Make an output to the current back buffer. So we register our commands, submit them into a queue. They run through our pipeline, and we output some image data to our current back buffer. The swap chain then flips the back buffer and the current buffer that is displayed, and thereby we show our rendered output. So right now we only have a swap chain. We actually do have the render targets, but we do not have any of the current components, which means that we really can't do anything with these back buffers. yeah, so that's our plan. To do. Uh, so to be able to register commands, we will need a so-called command queue. We will need one or more command lists for ease of use with their own command allocator, which is like a data structure that holds commands. The command list is the interface that you use to register all of the commands to the containing data structure, um, which is why you could, in theory, use several command lists for the same allocator, but that it gets somewhat obnoxious, and you have to synchronize that only one command list is so-called open for registration, and the other ones are closed, since you can only use um, a command allocator for one command list at a time. So there would be a lot of waiting. So it's far easier just to assign a command list to each its own command list allocator. Then we will need something like fences. Fences are synchronization objects that make sure that our GPU and CPU timeline doesn't get out of sync. We will be using specific fences for each command queue, since you can actually have different command queues. You can have the direct command queue, uh, which handles everything. You can have the copy command queue, which do a lot of the copying work, or you could have the compute command queue, which are compute calls to our GPU. Um, for instance, if you want to run a bit of complicated math on the GPU and uh, uh, utilize the parallel processing of the GPU, you could use a compute command line. It's also possible to do asynchronous work on uh, separate command queues. So for instance, if you need a certain set of computations to be able to apply effects on your rendering, you could use the compute command queue. Anyway, they will get their own fence so that they know how far they got. Um, we will work out how to structure it. For now, we are gonna start with more simple structures. So we will probably just have one command queue and a single fence for that. We will also need to be able to do resource transitioning, since DirectX12 ensures that proper synchronization is in place by making sure that resources have the correct state for whatever operation that needs to be going on. For instance, if you want to write to a resource, you can't also read from it before it's transitioned out of the write state. So yeah. Uh, yeah, DirectX12 is a lot of synchronization work, so if you're not into multi-threading in general, it can be a bit daunting. We will make it as simple as possible. Um, yeah. All right. For that, I've suggested some overall structures. I would like a CommandQueue manager, and a command list manager. The CommandQueue manager should track each CommandQueue and their uh, allocated fence. The command list manager should track each command list, their allocator, and perhaps even when they get applied for execution, they should store whatever fence they were um, sort of, yeah, whatever fence they're waiting for. Since we can only reuse the command list allocator after execution, as far as I remember. Let me just look that up. Yeah, I'm pretty sure you can only do that. Yeah, so the command lists need to know whatever fence they're waiting for in terms of their command allocator. And then we would like a simple manager of resource states. Eventually, that makes it possible to query whether a certain resource is in a certain state. Uh, if you want to do something like render graphing, where you structure your render calls, this could be helpful. We will do pretty simple structures in general, since we will not be creating a very sophisticated algorithm. And I will be doing everything from scratch, so there might be some deliberation on what to do. And I might have to look up a bit of documentation and previous work. So, let's see. Yeah. Whoops. Don't need that folder. Yeah, it was just different images. All right. Well, should be fine. Yeah. So let's get started. I think we should start by doing a uh, by doing a manager. Perhaps maybe just something related to commands instead of a manager. I'll be having this on a different screen. Perhaps, is that a nice name for a manager? Shouldn't be too long, shouldn't be too short. So we have a D12 CommandQueue manager. QMan sounds pretty fine. Then our CommandList manager will be CommandLman. Yeah, let's just go with it. Let's see. There we go. I'm unsure whether we want a separate CommandQueue wrapper. Maybe, well, we could always refactor it, but for now, we will do it like this. Let's see. And of course, declare the namespace. I'm getting really good at that, huh? So we don't mind being able to create an empty CommandQueue manager, but we do want to be able to initialize it. Perhaps we should use a bit of singleton patterning as well. Let's see. Yeah, private static. M instance and a public static get function. And declare the return M instance. Yeah. Then we would probably want something like an initialization method. Let's see. Let's see. We create our command queue. We might as well just copy that and leave it inside a comment for now. So we need a com pointer for our command queue. We also need a com pointer for a fence. And we would like some sort of, should we say, tracker for the fence. So some local variables. Uh, a current fence value of sorts. Let's see. So that we can always compare. So whenever we signal a synchronization point using a fence, we will always be increasing the current fence value, and that means that we can query whatever synchronization point is kind of like our waiting point before the command queue has executed everything, and thereby also whether our command allocator could be expected to be clear of commands, and thereby could be reset. So yeah, I think that is our basic structure for now. Remember that we could always do implementations of the direct, the copy, and the compute command queue types. We will just be keeping it simple for now. Of course, if you get a more complex application, you would have to make sure that you have different synchronization methods, and that you have some logic that handles whatever needs to be computed for a certain needs to be computed for a certain frame or something like that. Yeah, but for now we just create an interface that allows us to partly initialize our command queue and god damn it, I'm sorry, that's annoying. Yeah, so I prefer to segment things a bit, so the things that are related to our singleton pattern gets split up. Yeah. So first I do kind of like the methods of um, the interface or class or whatever, and then I do whatever is static, both methods and values, and then I do the internal private values lastly. Since it's rarely relevant to see what the interface actually stores of internal values. But static stuff is pretty relevant to have available. Okay, so we want a Microsoft COM pointer to our command queue. We could do an array for could do an array for each. We could do an array for each type of queue. As far as I know, you aren't helped by creating several command queues. I might be wrong on that, but as far as I know, um, due to some Intel analysis, I mean the actual company Intel did on parallel processing in terms of DirectX12. As far as I know, they kind of suggested that the whole command queue submission is a bottleneck in multi-threading. Therefore, I'm not entirely sure that you would want several command queues of each type. Perhaps if you do different priority queues, yeah, I don't know. Maybe I'm wrong. I probably am. Oh well, yeah. But for now, um, for now we do it like that. We could also do a 2D array, which would allow us to segment the queues into types and then have several queues of each type, but we won't be doing that for now. You can always do things more complicated, and that's not a priority right now. So let's see, is the fence? Yeah, that's the type. Yeah. And we want a unsigned int that is our current fence value. And I think that is it for now. So we want a command queue descriptor. As you can see, we need a device. So our device, will get passed into this method. Otherwise, we can't do anything. And then we will create our command queue, and we will not there. We will be using our address of our compiler. All right. I'm sorry. All right. Let's just comment that out. And we would like to include our CommandQueue manager. Perhaps we should just remove this and see if our... Nah, right now we can't. So let's say direct12 CommandQueue manager get dot init, and we pass in our device and get the device pointer. Then we would like to be able to does it copy it? No, it probably shouldn't, I think. Yeah, there might be a problem with this singleton pattern eventually. All right. Anyway, we want to be able to get a queue, or at least a pointer to our queue. And therefore we create that method. So now we have, let's see, I'm just gonna close these so I don't get confused. So right now we initialize them. If we do get the command queue and get the queue, hopefully everything works. Yeah, no errors, no nothing. We have a swap chain that got created properly. Great. But we're not done. We would also like to create a fence. Let me just see, do I have any syntax for that? Yeah, I might as well just show you. Since I think that is a fine habit to have. We want to use the device create fence. So once again, we use the fence. We initialize it as 0 usually. We store it in a com pointer, and we are allowed to use flags. I actually don't know what shared. A shared fence. Cross adapter. I actually don't know what shared fences are used for. Anyway, then we will use the create fence method. And we will pass in current fence value, since it should be 0 whenever we start the application. We will pass in null as flags. Oops. And we will pass in our fence address. Oh, okay. It doesn't accept that one. So let's see. Fence flag none. Even though it translates into null, it's not satisfied. All right. There we go. So now we create a fence and a command queue. Of course, we need to be able to do even more with our command queue, but it's kind of like integrated with our command lists and command list allocators, or rather command allocators. So yeah, we will be jumping back and forth between different structures and implement the functionality as we go along. All right. So maybe we should just uh, 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 maybe we should just create a let's see. Uh, we will just do an inline function here. Whoops. I'm unsure whether this should be inline as well. I actually think that it's so short. Let's just do inline. .get. This tells the compiler it should just write that function inline whenever it gets called instead of referencing a specific function on an object. Yeah, I think that is highly preferable. I'm just gonna check out some stuff. All right. Yeah. All right. We got set up with our command queue manager. Hopefully we won't get into trouble with this naming, otherwise we will just refactor it, but yeah. Let's move the files and declare a namespace. Let's see. Also declare the namespace here. Yeah. Let's copy this somewhat, since we will also only have one manager of our command list manager. let's see. Public for the static method, private for the variables. Yeah, should be fine. Static get. The reason why I don't do these inline is because we might add logic to um, uh, um, kind of like change our instance variable or initialize whatever needs to be initialized if it hasn't been initialized. Yeah, I think we need an initialization method as before, but first we will create a default constructor which allows us to create an empty command list manager. Actually, yeah, that's fine. Mm, actually, um, we should hide the constructor since we don't want anyone to be able to create our command list. Yeah. First the public methods, then the private methods. Yeah, I think that is better. Then we aren't supposed to create any more of those. Yeah, the static methods are able to create the one that gets created there. Alright, well, we need to create some command lists and some command list allocators. Mm. Yeah, so let's look up that method, create command list. It's also on the device, and it will take a command list type, uh, an allocator, an initial state, and uh, yeah, yeah, let me just look up. Mm. as you can see, the pipeline state can be set to null pointer since there's a little overhead. But perhaps we eventually would like to fill out that. We also need to be able to create a command allocator. That's also on the device. As you can see, a command list needs um, uh, a command list needs a command list allocator, and in our setup we need to create a an allocator for each, and yeah, that's just a structure. I should really get some decaffeinated coffee since I really like the taste of coffee. I guess I'm conditioned to loving it. Alright, so we need a COM pointer to a ID 12 interface D12. No, Direct3 D12 command list and command list. For now, just one. We will probably do. No, perhaps we should. Hmm, uh, we'll start out with one, but I'm pretty sure that we will go up to maybe 4 later on. Imagine that if we're gonna do a multi-threading setup, each thread should get their own command list and allocator and have a shared command queue. So threads should be able to build command lists um, either for different things or uh, parts of a scene where you divide it on over several threads. Uh, and yeah, we should have one command list and one allocator for each thread. Um, right now we will be doing single-threaded rendering, even if we decide to split off the rendering on a separate thread from our main thread and do it somewhat asynchronous. Um, um, we won't be uh, grabbing more than one, perhaps two command lists. So yeah, everything will be serial for now. Anyway, let's get on with declaring oh, uh, the command list list allocator. How's my spelling? Not great, apparently. Uh, let's see. Allocator, maybe. No. Command allocator. It's not because it's not called a command list allocator. All right. And we would also like a fence for synchronization purposes. Since we will be fetching whatever synchronization point the command queue has next, we will be calling this a waiting fence. Since we are only allowed to reset our command list allocator after the commands have been um, um, submitted and processed in the command queue. Whenever we are allowed to reset the command list allocator is when the GPU gets to that synchronization point and confirms that everything has gotten processed. Therefore, we need to register whatever fence um, whatever fence the command queue decided to give us. Yeah. All right. Let's do some initialization. We will probably need the, the device, as you can see from the documentation. So let's see. We will just write that out as well. Yeah. So we want to create the command allocator, and we need to decide on a command list type. We will do direct. There's also a bundle. You have to do experimentation to find out whether a bundle is optimal. And there's also the compute and copy command lists, which correspond to the compute and copy command queues. Direct is everything. Uh, as you can see, yeah. So that is our command list type. We will, oh, maybe I actually forgot. Yeah, we forgot to use our helper function, since we certainly wouldn't like to do anything if we aren't able to create either a fence or a command queue. The same goes for probably this function, but create, let's see, create command allocator, and we will pass in the type, and we will pass in our com pointer. Yeah. Did I miss a parentheses of sorts? Get address of. There we go. And let's just add another one. Eval gxe eval h result. Yeah, it returns an h result. Create an allocator, and we also want to call the create device, create command list. We don't have multiple GPUs. We use the type of direct. We want to get a pointer to our underlying command list, or rather our associated command list allocator. We don't want to do a specific pipeline state for now. We want to use our helper to send our command list into our com pointer, and we want to evaluate the result of this call. All right. Let's see. I don't think we need the devices for now. Let's see. So if we include our command list manager, lman qman, for some reason I really like that naming convention, or rather naming. Let's see. We initialize our lman, and let's see how many objects we are able to create. Okay, we have a command list allocator, a fence. We have a lifetime tracker. I think the command list allocator that gets created here is is for the swap chain. So the CommandQueue, there's two allocators, there's two graphics command lists. Let's see. I haven't forgotten something internal, right? Let's see the swap chain. Maybe no, we don't create them. So if I disable the swap chain, I think we would get only one command list. Yeah. Okay, we still get a queue, but yeah. So this is the objects that we just created. It's probably because the swap chain handles the flipping of uh, the back buffer and front buffer in a separate command list, I would think. Yeah. So right now we have our objects. And I think I need a short break, and this is a great point to uh, round this section off and create segmentation of the video. Yeah, so hopefully this has been helpful so far. Remember, if you find any of this content helpful, uh, like, subscribe, follow, or perhaps even make a donation. Yeah, hopefully I'll be seeing you around.